So you can see our problems are getting a little bit longer each step of the way. So here I have how many terms? 1, 2, 3, trinomial. How many terms? 1, 2, 3. Remember, addition and subtraction separates terms. So we have a trinomial times a trinomial. Now I'm definitely not going to show you FOIL, because this is not by and by. You have a try and a try. How can I do this problem? Well, you could do distributive property, but you're going to get a long list because it's this was this, 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 this was this. So it's going to be 9 terms going straight down in the list. So instead of creating one long list that won't even fit my board, I like the rectangle method. So remember, step 1, count how many terms in the first one, count how many terms in the second term. Step 2, draw a big rectangle. Right? Notice it's a little bigger than the other two because I got more terms. Now I'm going to have to draw in some columns and some rows. So this one, again, for some reason, I always say this is rows, and this is my columns. So draw 3, try means 3, rows. So there's row 1, there's row 2, there's my third row. Now draw 3 columns. Column 1, column 2, and then column 3. I don't have to split that any further. Notice 3 times 3 means that I have 9 individual squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's place these guys on the outside edges. Because I called this rows, it's going to go here. Because I called this columns, I'm going to put it on top of my columns. When I write it out, make sure you include the sign. So make sure it's negative 5c, not just 5c. And then positive 2 here. And then here, 9c squared plus 3c minus 4. So it's all set up. Now I just have to fill in the individual squares. How do I do that? Remember, the next step has to deal with using the product rule. To fill in the individual squares, ask yourself, do you have like bases? Look to see if you have the same letter, basically. If you have the same letter, then keep the same letter and just add the exponents. Then multiply any coefficients and constants together. So c squared, look, the same letter. So we're going to keep the same letter. 2 c's on top, 2 more to the left. 2 plus 2 is 4 of them. What do I do with these coefficients? Multiply. 9 times 8 is 72. Next box. Doesn't matter which box you go to. This one. C on top, but 2 to the left. Remember, it's understood 1. 1 plus 2 means I'll have C, but 3 of them. C, kept the same base as C. Coefficient, multiply. Positive 24. This one, no C's, but 2 are here. Remember, add. 0 plus 2, I have to bring over the C squared. They don't disappear. The 2 are still there. This is a constant now, but we still multiply it with the coefficient. Positive times a negative means I'll get a negative 32. This one. 2 C's on top, 1 C to the left. 2 plus 1 is 3. Keep the same C. And then coefficient, multiply. Positive times negative, you know it's negative. C on top, C to the left. Keep the same C base. 1 plus 1 is 2. This times this, negative 15c squared. Finally, negative 4 constant times this. Well, you still have c to the first. This times this, 2 negatives will become positive when you multiply. This guy, c squared and a 2, 18c squared. How did I do that? 2 c's, no c's, that means I still have 2. and I multiply the coefficient with the constant to get 18. Same thing here. 1c, no c's, still have the 1 on top. And 3 times 2 is 6. And then this times this, negative 8. When you do this rectangle method, there's only one corner at most that will be a constant. All the rest will have a variable. Okay? Only this lower corner, constant times constant, will have no variable, no letters. Now that you filled this out, let's see if we have any like terms. Remember why I like this method so much. This is my highest degree. Remember, they're all C's, so I don't have to worry about alphabetical order. This is the only C to the 4th. C cubed. Here and here. See how they're lining up diagonal of each other? This is a negative, this is a positive. So I know that my answer here will stay C cubed. When I fill in the individual squares, I add it. 2 and 2 is 4. But when I collect, 3 stays 3, not to the 6th power. So that kind of helps you determine filling in the squares, add exponents. Collecting, exponent stays the same. And then 24 and a 45, you should know negative is going to win. And the difference is 21. Notice C squared, C squared, C squared. So it's going to stay C squared. Remember, collecting. Keep the same variable part. Now let's just do 2 at a time. We have a negative and a negative. So 2 negatives you know you're going to add. So this and this is going to be negative 47. But we still have to combine it with a positive 18c squared. So notice it stays c squared. Who's going to win? Negative or team positive? 47 is going to definitely win, so that's team negative. And then the difference between this and this, we're going to get 29. Now, single C's. We have this and this. See how they're lining up diagonal in this direction? That's why I love this method, because I don't have to hunt to see what matches. 20C, 6C, they're both positives. Remember, collecting. C first has to say C first. And then 20 and 6. Remember, 2 positives. And then team 20 is going to win. So I'll squeeze in a plus sign there. And then this is my only constant. So I put in a minus 8 at the very end. So this big problem was more organized, in my opinion, by doing the rectangle method. And I saw what my like terms were to get my final answer. Okay? So try to learn the rectangle method if you're that person who likes to be more organized.